Well, this is the first video for Math 95. Our first assignment is about solving inequalities, which you should have had some exposure to in a previous course. So this may be a review, it may not, but in any event, this is what we're going to start out with. The idea here is that solving inequalities works using exactly the same properties as solving equations with one important difference. And that difference is related to the fact that if you say x equals 7 and 7 equals x, you're saying the same thing. It doesn't matter which side of the equal sign these things are on. It's both sides are equal to each other. Now, if you say a greater than 5 and 5 greater than a, now you're saying two opposite things. This says that a is bigger than 5. This says that a is smaller than 5. Okay? Now, because of this issue of switching sides, if you multiply or divide by a negative, you're supposed to flip this symbol around. Okay? I'll talk more about that when we go over some problems, and I'll talk about exactly why that is. Okay? So, here's the thing. Well, let's take an equation. Let's say we have negative 3x equals 6. Now here's the long way, is to add 3x to both sides and subtract 6 from both sides. And if we do that, we get x equals negative 2. Okay? The other thing that we can do here is just divide on both sides by negative 3, and x equals negative 2. Now notice how they're on different sides, but that doesn't make any difference. Okay, now, what if we do this with an inequality? What if we say negative 2y greater than 8? Okay, let's solve it the first way. Add the 2y over here. Subtract the 8. Now notice that this doesn't change. We haven't done anything that's going to make this thing change. Now we divide on both sides by 2. We get y is less than negative 4. Now, if we divide on both sides by a negative 2, if we don't flip this around, we get y is greater than negative 4. But this just told us that y has to be less than negative 4. So if you want to use this, it's not really a shortcut, but it is certainly shorter than going through this process. Okay? So the issue is that if you multiply or divide by a negative number, it has the same effect as moving your variable to the other side of the equation. Okay? And so for that reason, if you multiply or divide by a negative, you need to flip that inequality around. You can do your problems this way and never have to worry about flipping this symbol around. And I sometimes do that. I sometimes switch sides just so I don't have to worry about this. How you approach these problems is up to you, so long as what you're doing is correct. Okay, so there's the big difference between solving equations and solving inequalities. So let's look at some examples from the assignment. All right, let's see here. Problem 2. With these assignments, typically what I do is I'll use the even problems as examples, and then I'll assign the odd problems, and your answer key will have the answers for the odd problems. All right, problem 2. Negative 6 greater than s over 3. Okay, so to get this s by itself, I'm going to multiply on both sides by 3. Okay, so these cancel out. I'm left with s. Over here I get negative 18. Now, did I multiply or divide by a negative number? No, I did not. I multiplied by a positive number. Even though there was a negative in the problem, and this number over here is negative, I did not multiply or divide by a negative number. So this will stay the way that it is, and there's our answer, s less than negative 18. And it's a good idea to get in the habit of putting these on a number line so that we can get a visual representation for that answer. Okay? All right, let's see here. Problem 4. Got negative 5w less than or equal to 15. Now I'm going to divide on both sides by negative 5. Over here we'll get a negative 3. And because I divided by a negative number, this thing needs to flip around and say w greater than or equal to negative 3. And if we put this on a number line, there's our negative 3. We'll color that in for the equals to, and then we want the variable to be greater than that value. All right. Let's see here. Problem 6. We've got 2v plus 1 greater than 7. So now I'm going to subtract 1 from both sides. So now sometimes people see this negative and they think, oh, I better flip that around. No. Am I multiplying or dividing by a negative? No, I'm not. I am subtracting 1 from both sides. So these cancel out. This stays the same. This is 6. This also stays the same because I didn't multiply or divide by a negative. Now I'm going to divide on both sides by 2, and we get v greater than 3. And on the number line, it'll look like this. Okay, let's see here. Let's do a couple more. Let's see here. Problem 12 is kind of interesting. Here we've got 12 minus 3/2 c greater than 0. So you've got some choices about how to approach this problem. Like I said, sometimes I just like to change sides to keep this thing positive. So now I've got 12 greater than 3/2 c. If you're using a calculator and you want to divide by 3/2, do be careful with that. It depends on the calculator you're using. Sometimes you'll need a parentheses around that 3/2. I'm in the habit of multiplying by the reciprocal, just because that's how I learned to do it. And it's also quicker for me to do that than it is to pick up the calculator and type in 12 divided by 3/2. So this will be 8 greater than c. And so our answer here is that c should be less than 8. Remember that this thing always points at whatever is smaller, right? If you have c less than 8 or c less than 8, one thing to think about, in the historical record, the mathematician who developed this symbol for equality chose 2 equivalent line segments because to him that represented equality. What could be more equal than 2 line segments that are exactly the same length? Now, watch what happens if you pinch this side down, right? Then the opening there in between those lines gets smaller on this side and bigger on this side. And in the same way, that means this number is bigger, this number is smaller. Okay? It's important that you understand which side is bigger and which side is smaller when you're dealing with an inequality. All right, what else? 14. 14, we've got variables on both sides. 3x minus 4 less than 2x plus 5. Now this is your choice as to how you'd like to approach this problem. I like to keep the coefficient of the variable positive. So I'm going to move the 2x's over to there. Okay? That'll leave me with 1x here, minus 4, less than 5. Add the 4 to both sides. Now notice I haven't multiplied or divided by a negative, so this thing never changes. And my answer is x less than 9. 18. Here we've got 4 times 2 minus v greater than or equal to negative v minus 5. Okay, so let's distribute. 4 times 2 is 8 minus 4v greater than or equal to negative 1v plus 5, right? The negative times the negative will give us a positive 5. All right, same thing. I can move the v's over to here if I wanted to, or we can move these over here. That's what I'm going to choose to do. I'm going to add 4v on both sides. That'll leave the 8 over there. And again, if you're not sure what this is going to turn out to be, please use your calculator for positives and negatives, okay? Or just to check what you suspect the answer will be. Let's see. Now we're going to subtract 5 on both sides. Those cancel out. 3v less than or equal to 3. Divide on both sides by 3. And we get v less than or equal to 1. So we'll color that in. And all the numbers less than or equal to 1. Okay, so there's the review for solving inequalities. Now, on the back, or in the second page of this assignment, we also have some information and exercises about intersections and unions of sets, because that material is on the final exam. So let's take a look at this page. So this works with sets of numbers or letters or really anything at all. So let's look at what we're working with here. In the first group, we've got set D, 1, 2, 5, 6, 9. Set F is 3, 4, 5, 6, 7, 8. And set E is 0, 6, 7, 8, 9. 0, 6, 7, 8, 9. Okay, so when we're working with sets, this symbol stands for union. And that means we want everything from all the sets that we're taking the union of. This means intersection, and that means we want only the things that are members of both sets. Okay? So, let's look at these examples. Problem 20, D union E. Okay, so we're definitely going to want everything from set D, 1, 2, 5, 6, 9. And then we want everything from set E. So we also want the 0. Let's see, we've already got the 6 listed, so we don't list it twice. And then we want the 7 and the 8, and we already have the 9. So there we go. You can rearrange these if you'd like so that they're in numerical order, but that doesn't really matter. Okay? All right, problem 22, E intersection F. So now we only want the things that both E and F share. The 3 is not in both, neither is the 4, neither is the 5. The 6, 7, and 8 are in both sets. So we'll definitely list those. Let's see, what else? The 0 is not in both, and the 9 is not in both. So this is it. For E intersection F, we just have 6, 7, and 8. And problem 24 is D intersection F. And let's see, D intersection F, we don't want the 1 or the 2. The 5 is in both, and the 6 is in both. And so there we go. Okay, the 9's not in both, neither is the 3, neither is the 4, the 7, or the 8. Okay, so what's in both of them? Just the 5 and the 6. Okay, well let's look at a couple of problems from the bottom of the page there where we've got those different sets. I, J, and K, I believe. J, K, L, and M. All right, let's see what we've got here. Set J, 1, 3, 5, 7, 9. K, -3, -1, 1, 3, 4. L, 1, 2, 3, 4, 5, 6, 7. And then M, 3, 4, 5, 6, 7. And then problem 26, we want K intersection with L. So let's see, what do they both share? K and L. No negatives in L, so these two are out. Let's see, 1, 3, and 4, 1, 3, and 4. So that's what we've got. 1, 3, and 4. And these negatives are not in here. Anything bigger than 4 is not in K. And so K intersection L is just the 1, the 3, and the 4. Problem 28. J intersection M. Let's see, J and M share the 3, the 5, and the 7. And that's it. The 4 is not in J, and the 6 is also not in J. And then problem 30, K union J. All right, so we definitely want everything from K, -3, -1, 1, 3, and 4. Now, anything else from J that we're missing? We've already got the 1 and the 3. What else? We need the 5, the 7, and the 9. And there we go. So we've got everything from J, everything from K. There's a little bit of overlap in there, but we don't need to list those twice. Okay, so that's it for our first assignment. Like I said, hopefully that material about inequalities was review. In the next assignment, we'll see a little bit more complicated problems with inequalities, and then we'll move on from there and talk about some absolute value problems.